Hello all, my name is Sujin George and welcome to this lecture series of surveying. In the previous videos, we had discussed the relationship between various parts of a reverse curve. In that, we had discussed the case 1a and case 1b. Today we will discuss the case 2 for parallel straights. Now we know that a reverse curve, it is used when the straights or the tangents, they are parallel to each other and they do not intersect. So we can insert a reverse curve in between them. Like for example, these are two straights which are parallel to each other, and a reverse curve could be inserted between these two straights. For example, these are two roads and a reverse curve has to be established between these two roads. So it can be done easily. So we will see how it is done in the second case. Consider this figure. In this figure, these are the two parallel straights. Suppose this is straight AT1 and this is straight T2C. These two straights AT1 and T2C, they both are parallel to each other. And this is the reverse curve T1E and T2E. This curve is T1E and this curve is T2E. We know that T1 is known as the point of curve, T2 is known as the point of tangent, and E is known as the point of reverse curvature. Now this curve T1E, it has a central point O1, and this curve T2E, it has a center point O2. Now let R1, this be the radius R1 for this curve T1E. This is R1, so this will also be R1. Let R2 be the radius for this curve T2E. So this is R2, so obviously this will also be equal to R2. Okay, this is the radius of this curve T2E. Let this be the central angle delta 1 for this curve T1E, and let this be the central angle delta 2 for this curve T2E. Let the line joining this T1, T2, let it be denoted by capital L. Let the horizontal distance between this T1 and T2, this is the horizontal distance between T1 and T2, let it be called as small h. And let the vertical distance between T1 and T2 be called as small v. So here we need to find these parameters V, L and H. Okay. Now as we know, this is a tangent AT1 and this is tangent CT2. Both are parallel to each other. Since these two are parallel to each other, the radius will be at 90 degree. The radius, it will be at 90 degree to both the tangents. So obviously this O1T1 and this O2T2 both will also be parallel to each other. O1T1 will also be parallel to this O2T2. So this angle, that is delta 1 and delta 2, both will be same, because if there is a line like this and an angle is made like this, so if this angle, these two angles will be same to each other. Okay, so if this is delta 1 and this is delta 2, so delta 1 will be equal to delta 2. Okay, let us call it as delta. Fine, so here this delta 1 will be equal to delta 2, let us call it as delta. So this is the condition in this, that condition is that delta 1 is equal to delta 2 is equal to delta. Okay, so what is given over here? In this, the parameter that is given is these two radius R1 and R2, they are given. Also, these central angles delta 1 and delta 2 are also provided. But we are here, it is the condition is that delta 1 is equal to delta 2 is equal to delta, and also these two radius are given and central angles delta 1 and delta 2 are given. So what is required to find out? The required parameters are to calculate other elements of the reverse curve. We have to calculate other elements of the reverse curve. Now here, if we consider, we have made a line over here. This line, let us call this as BD. Let this be line BD. So this line BD is actually parallel to both the tangents. Okay, this line BD is parallel to both the tangents. And we are assuming that this delta 1 is equal to delta and this delta 2 also is equal to delta. Okay, this is what we are assuming. So now if we consider this triangle O1BE, we are considering this triangle O1BE. So let us make a triangle like this over here. So this is O1, B and E. Here the angle is given as delta, and this is O1E is at the radius R1. It is the radius R1. So what will be cos delta? Cos delta. Cos delta will be equal to adjacent upon hypotenuse, that is O1B upon R. So O1B will be equal to R cos delta. O1B will be equal to R cos delta. Again, what will be sin delta? Sin delta will be opposite upon hypotenuse. This is R1. Okay. So here this will be BE upon R1. So we have BE is equal to R1 sin delta. This BE will be equal to R1 sin delta. Fine. Now if we consider triangle O2DE, this triangle O2DE. So let us make that triangle over here. This is O2, D and E. Here this angle is given as delta and this is the radius R2. So what will be cos delta? Cos delta will be adjacent upon hypotenuse, that is O2D upon R2. So O2D will be equal to R2 cos delta. Also sin delta will be opposite upon hypotenuse, that is ED upon R2. So we get ED is equal to R2 sin delta. ED is equal to R2 sin delta. Okay. So these parameters we found out, these will be important in deriving the formulas. Now consider this length, this radius O1 T1. So this O1 T1, this O1 T1 is equal to this O1B plus BT1. It is equal to O1B plus B T1. So what will be B T1? B T1 is equal to O1 T1 minus O1 B. B T1 is O1 T1 minus O1 B. But here O1 T1 is R1. So this is R1 minus this O1B. We found out the value for O1B. O1B was equal to R1 cos delta. So substituting this value over here, this will become R1 cos delta. So we get BT1 as R1 into 1 minus cos delta. Okay. Similarly, let us consider this line O2 T2. So this O2 T2 is equal to what? It is equal to this O2D plus DT2. O2D plus DT2. So DT2 will be equal to O2T2 minus O2D. But here this O2T2, it is equal to the radius R2. So this will be R2 minus, and O2D we already calculated from here. See, O2D is equal to R2 cos delta. So this will be R2 minus R2 cos delta. So DT2 will be equal to R2 into 1 minus cos delta. Okay. Now here, if we consider this distance V, this vertical distance V. So V is equal to this V, it is equal to this T1B plus DT2, this T1B plus this DT2. So it will be T1B plus DT2. So BT1 is this and DT2 is this. So substituting, this will become R1 into 1 minus cos delta plus R2 into 1 minus cos delta. So we get V is equal to R1 plus R2 into 1 minus cos delta. Okay, we got the value for small v, that is the vertical distance between T1 and T2. Now, in this figure, consider this curve T1E. This length T1E, it is the long chord for this curve. Okay, so here T1E is equal to length of long chord for curve T1E. This is equal to the length of long chord for curve T1E. So from the elements of simple circular curve, we know the length of long chord. The formula for length of long chord is given as 2r1 sine delta upon 2, where this r1 is the radius of this curve and delta is the central angle of this curve. Okay. Similarly, this T2E, if we consider this curve T2E, so this length T2E, it is the length of long chord for curve T2E. For this curve T2E, this is the length of long chord. So the formula for length of long chord will be given as 2r2 sine delta by 2, because here r2 is the radius of this curve, r2 is the radius of this curve and delta is the central angle for this curve. Okay. So we can find out the length T1 T2. This length T1 T2, length T1 T2 is equal to this capital L. is equal to this T1E plus this T2E. So L will be equal to T1E is this, that is 2R1 sine delta by 2 plus T2E is this 2R2 sine delta by 2. So this can be written like 2 into R1 plus R2 into sine delta by 2. Okay, so this is the formula for the length T1, T2, that is capital L. Fine. So this capital L, we have calculated this small v, that is the vertical distance between T1, T2, this length, total length T1, T2. Now from this figure, if this angle is delta, so we can say that this angle will be equal to delta by 2, because this is the curve, that is O1, T1 and E. We are considering this curve O1, T1, E. So this angle is given as delta. Now if a deflection angle is made like this, see, these are the tangents. Okay, this will be 90 at 90 degree to both the tangents. So this angle, central angle is delta, so the deflection angle will also be given as delta. This deflection angle, if this deflection angle is delta, so these tangent lengths will be equal to each other. And if these tangent lengths are equal, so we know from the property of triangle that this exterior angle will be equal to the sum of the two opposite interior angles. So these two angles should also be equal to each other, and that should be equal to delta. So if this is delta by 2 and this is delta by 2, so this delta by 2 plus delta by 2, it should be equal to delta. So hence we can say that this angle is equal to delta by 2. Okay. So if this angle is delta by 2, and if we consider this triangle T1, T2 and this, let us call this as F. So if we consider triangle T1, T2, F. In this triangle T1, T2, F, this is T1, T2 and F. This F is 90 degree. Okay, F is at 90 degree. This T1, T2, this angle is given as delta by 2. And this complete T1, T2, it is given as L. And this height is given as V. This height, this vertical distance is given as V. So sine delta by 2, if we apply sine delta by 2, that will be equal to opposite upon hypotenuse, that is V by L. So sine delta by 2 is equal to V by L. So here if this sine delta by 2 is given, we can substitute over here V by L. Okay. So here if we substitute from this equation, L is equal to 2 into R1 plus R2 sine delta by 2. So this will become L is equal to 2 into R1 plus R2 into V by L, because sine delta by 2 is equal to V by L. So this will become L square is equal to 2V into R1 plus R2, or it can be written as L is equal to under root of 2V into R1 plus R2. Okay, so we have two equations for L. One is this and the other is this. Next, we need to find the horizontal distance h, this horizontal distance h. So this horizontal distance h is equal to this distance BD itself. Okay, h is equal to this distance BD, and BD is equal to BE plus ED. BE plus ED. So BE and ED values we have already calculated over here. BE is R1 sine delta and ED is R2 sine delta. So this will become H is equal to R1 sine delta plus R2 sine delta. So H will be equal to R1 plus R2 into sine delta. So this is the formula for calculating the value for H. Now we have got the values. Now these values are calculated if R1 is not equal to R2 and delta 1 is equal to delta 2 is equal to delta. Okay. So the equations are given as this: V is equal to R1 plus R2 into 1 minus cos delta. L is given as 2 into R1 plus R2 into sine delta by 2, or L is also given as under root of, this is under root of 2V into R1 plus R2, and H is given as R1 plus R2 into sine delta. These are the three equations, V, L and H. Now in a special case, if R1 is equal to R2 is equal to this radius R, assume that this R1 is equal to R2, which is equal to this radius R. So how this equation will change? The first equation will become V is equal to, this will become 2R into 1 minus 2R into 1 minus cos delta. The second equation will become L is equal to 2 into 2R, that is 4R into sine delta by 2, or here it can be written as 2V, this will become 2R. So 2 into 2R will become 4R, so this can be written as 4RV, or 2 under root of R into V. This will become under root of 4RV or 2 under root of R into V. And the third equation, that is H, will become, this will become R plus R, that is 2R sine delta. Okay. So this case arises if R1 is equal to R2 is equal to R and delta 1 is equal to delta 2 is equal to delta itself. So mostly when we solve numericals on this, or when we set out the reverse curve, this R1 will be equal to R2 will be equal to R only, and hence we will have to use this special case only. Okay, we will have to use these formulas when R1 is equal to R2 is equal to R. Fine.